Welcome back, everyone, to AP Pre-Calculus. This is the Unit 2B exam review. Let's get right into it. All right, so here's the test overview. There's going to be two sections, a no calculator section and then a calculator section. The no calculator section will have 11 multiple choice questions, each for 5 points, and then 6 short answer questions, each for 2.5 points. That's going to be a total of 70 points. So there is 70. And then the calculator section will have two 6-part short answer questions, and those will be each worth 2.5 points there. That's going to be a total of 30 points there. So for a total of 100 points. This short answer question is going to be solving and simplifying equations. And then these two, this one's going to be working with functions. And then this one is going to be that story problem, probably in a logarithmic setting. All right, so let's work through each one of these problems for 1 through 3. Just write each exponential equation in logarithmic form. So remember, if we have a to the power of b equals c, the equivalent log form is going to be log base a in the subscript of c equals b. So here, this would be log base e of 7 equals x, but we should write this as ln of 7 equals x, because ln is how we commonly write log base e. This one I'm going to write as log base 5 of 4 equals x. There we go. And then for this one, this is going to be log base 10 of x equals 4. However, we typically just write log base 10 as just log. So that's perfect for 3. For 4 through 6, we're just going to convert it the other way around. So this is going to be log base e x equals -2. So then e to the power of -2 is going to be equal to x. So that is our answer for 4. This is going to be 10 to the first is equal to x. Because remember, without it written, it's an implied log base 10. And then this is 7 to the power of x equals, and then that whole thing, e to the power of y. Right, so those are the first 6. Number 7, what is the value of the expression log base 10 of 100 minus log base 3 1 over 9? So here, let's take each one and let's just convert it into just a number. So log base 10 of 100 is 10 to what power will get you 100? That's going to be 10 squared is equal to 100. So this is going to be equal to the number 2. So let me rewrite that a little nicer. That's just the number 2 minus, and now what is log base 3 of 1 over 9? That's 3 to what power will get us 1 over 9 is really what this is asking. And so I know 1 over 9 is 3 squared. So 3 squared equals 9, which means 3 to the power of -2 will be 1 over that. So that is what we need here. So there, 3 to the power of -2 equals 1 over 9. So this is going to be minus -2. And then 2 minus -2 is 2 plus 2, which is 4. So 4 should be our answer for number 7. Right, number 8. The graph of a logarithmic function is given. Which of the following is true about this function and the graph of this function? So here this is increasing, so we can eliminate C and D. And then we also know the rate of change is decreasing because it is concave down, and so B should be our answer here. For number 9, in a semi-log plot, which of the following pairs of functions appears linear as parallel lines? This is going to be a question that's very similar on your test and was very similar in the notes for 2.15. And so remember, a semi-log plot will turn exponential equations and make them appear linear. And so the two exponential equations are C, which is our answer here. And so exponential equations will appear linear, and then parallel lines are really just because they have the same base, and the slope of the linear lines on how they look is based on the base in the form a times b to the power of x. All right, number 10, the logarithmic function k is given by k of x is equal to 4 log base 10x. Choose the correct words to describe k, whether it's increasing or decreasing, or concave up or concave down. And so here, we just want to look at the general shape. And the main thing the only thing you're going to look at is whether your a value in this form is going to be positive or negative. In this case, a is positive, so it should look like this. If a was negative, it would look like the reflected version, so like that. But we're not worried about that right now because a is positive, so it's going to be like this, which means it is increasing because it's going up as you go from left to right, and then it is going to be concave down because it's a downwards U shape. So that should be our answer for number 10. Number 11, the table gives values of function f for selected values of x. Which of the following is a verbal representation of the inverse? And so taking a look here, we're going to have x, and then you're going to have the inverse of f of x there. And now let's plot our points, right? And so to find our inverse, all you have to do is swap your x and your y values. So this becomes 4, 12, 36, 108, and then this becomes 2, 4, 6, and 8. All right. And remember, this is the question asking about the inverse, not the original function. So what type of function is this? Well, we see an addition rule in our x values, and then we see a multiplication rule times 3 in our y values. And this is going to be now an example of an exponential function. So the inverse is exponential, so we can eliminate a and b. And then with the input values increasing by 2, that's correct. Every time the output values, your y values, triple. That's good. So C is our correct answer. D is just the input and output values switched, which would make it wrong. So C is our correct answer for 11. All right, number 12. What type of line does an exponential decay curve look like when it's plotted on a semi-log plot? And this is going to be just a decreasing linear line. So B should be our answer there. And now, what type of line does an exponential growth curve look like when it's plotted on a semi-log plot? This is going to be an increasing linear line. So A is going to be our answer for 13. All right, 14. Consider the two functions f and g given by f is log base 5x plus log base 510, and then g of x equals 3. What are the intersection points? So we just want to set them equal to each other and solve for x. And so here we can combine this into log base 5 and then multiply the insides equal 3. Then let's convert this to exponential form. So that's going to be 5 to the power of 3 equals 10x. 5 cubed is 125 equals 10x. And so 125 divided by 10 is going to be 12.5. Or you could have 25 over 2 as your x value. So either one of those would be acceptable as an answer here. All right, this one's pretty easy. Simplify this function ln x to the negative fourth into the form a times ln x, where a is a constant. And so here, we just take this power and then you move it out front. So this should then be negative 4 times ln x. And that is our answer for 15. Right, 16. The function g is given by g of x is log base 11 of x. What is the value when you plug in 121 for x? Or 1 over 121 for x. What is this equal to? And so that's going to be, let's convert this to exponential form. That's going to be 11 to what power will get us 1 over 121? Well, I know 11 squared is equal to 121. So then 11 to the power of negative 2 should be 1 over that. So then negative 2 should be our answer. So this should be negative 2 there. All right, 17. The function p is given by ln x, and the function r is given by 1. For what values of x will this intersect? So here we just want to solve this equation. This, remember, is log base e of x equals 1. So then e to the first equals x, and so then x is just e. So that is our answer for number 17. Number 18, which of the following expressions is equivalent to ln square root y, or square root x, over 3y to the fourth, where x and y are positive constants. So here, let's split this up first into ln square root x minus ln 3 minus ln y to the fourth. That doesn't match any answer choices, so let's then convert every exponent and move it out front. So this is going to be ln x to the 1/2 minus ln 3 minus ln y to the fourth. Moving those out front, you should get 1/2 ln x minus ln 3 minus 4 ln y. Taking a look here, that should match up with answer choice C, so C should be our answer there. All right, number 19, a biologist is studying the growth of bacteria culture in a lab. The population is measured every hour. The data shows that the time since the start of the experiment passes every 5 minutes. So here, when you increase it by 5 minutes, 5 minutes, 5 minutes, the number of bacteria approximately triples. So this is times 3, times 3, times 3. What type of function is going to be best used to model this? And so here we see an addition rule up top. We see a multiplication rule in our outputs, our y values at the bottom. And so this is going to be an exponential function. So here, the only exponential function is a times b to the power of, in this case, t is like our x variable here. All right, number 20, which of the following graphs could represent data in a semi-log plot that contains the point 2, 35? So for a semi-log plot, remember we cannot have equally spaced input value or y value intervals, which a and b both have, so we can eliminate those right away. I don't know why I circled them. Let me just cross them off. So A and B are out. Now taking a look at C and D, we need the point 2, 35. Here, this is 1, that's 2. This might be 2, 1 point something, and so it's not C. It has to be D, which if you take a look right here, that does match, right? 10, 20, 30, 40. So 35 should be somewhere in between. So D is our correct answer for number 20. All right, this next one here, we need to rewrite these two equations and simplify them. The first one, we're putting it in the form 3 to the power of ax plus b. So rewriting this, I'm going to write 9 as 3 squared. And then this whole thing is still to the power of x plus 4 times 3 to the power of 4x minus 1 all over to 3 to the power of x. This is then 3 to the power of 2x plus not 4, but 8. So remember to distribute that 2 to both terms, times 3 to the power of 4x minus 1 over 3 to the power of x, simplifying the numerator. This is 3 to the power of 2x plus 4x is 6x, 8 plus negative 1 is plus 7, all over 3 to the power of x. And then this is 3 to the power of 6x minus x is 5x plus 7. So that should be our answer for part A. Part 2, rewrite this with a logarithm with a base of 3 in just one simple expression. So this is going to be log base 3 x squared, so move the 2 to the exponent, plus log base 3 x to the fourth, moving that 4 to the exponent. This is equal to log base 3 x to the 6th by multiplying x squared times x to the fourth. And that should just be your answer here. Part B, let's solve these equations. So solve when this is equal to 6. So 3 plus log 5x equals 6. Subtract 3 from both sides. Log 5x equals 3. This is then, we're going to convert this to exponential, which is 5 cubed equals x. And so x equals 125. That's our answer for number 1. Number 2, 3 to the power of 2x times 3 to the power of x plus 4 equals 27. Simplifying this, we get 3 to the power of 3x plus 4 equals 27, which is then 3 to what power will get us 27? That's going to be, we know 3 cubed is equal to 27. So let's honestly, what we can do is we can, replace that 27 with 3 cubed. So let's do that. And now we're going to set the two exponents equal to each other. So this is 3x equals -1. X equals -1/3 should be our answer there. All right. Part C, this is going to be an A method problem. Part C will typically be the only time you see the A method. And so here, this is going to be, we want to see where is this equal to 0. So we have log 8x, and this whole thing is squared, minus 3 times log 8x plus 2 equals 0. And so here I'm going to make the substitution that as a is equal to log 8x. So this now turns into a squared minus 3a plus 2 equals 0. This is going to be a minus 2, a minus 1 equals 0, a equals 2, a equals 1. Solving this, now that you have a equals 2 and a equals 1 as your two solutions, let's plug this back in. So log, and then remember this is an implied base 10 equals 2, and then log base 10, 8x equals 1. Setting these both to exponential, 10 squared equals 8x, 10 to the first equals 8x. 10 squared is 100 equals 8x. Divide both sides by 8. You should get x to be 100 over 8, which is 25 over 2, or 12.5. So that should be our answer for the first one. And then for here, 10 to the first is just 10 equals 8x. Divide both sides by 8. 5 over 4 is equal to x. So that should be our answer for the second solution. And both of those would work. You can plug them into the log. You won't get any negative numbers. And so those are both our solutions for that one there. All right, number 22. In May 2011, at time t equals 0, 65% of US adults did not own a smartphone. In November 2016, t equals 5.5, only 23% of US adults did not own a smartphone. The percentage of US adults that did not own a smartphone can be modeled by a logarithmic function s of t. Take note of this t plus 1. Where S of t is the percentage of US adults that did not own a smartphone, t years since May 2011. So here we can first write two equations that can be used to find a and t. So what we're going to want to do is find our two coordinates to start with. So this is a little confusing to gather from the story problem, but it is 0, 65, and then 5.5, 23 are two coordinates. Plugging them in, this is 65 is equal to a plus b ln, and now it's 0 plus 1. So remember that plus 1 if it's given to you, and that is our answer for the first equation. The second equation, 23 equals a plus b ln 5.5 plus 1, and that should be our answer for AI. Part 2, find the values of a and b. This is simply just done using Desmos. Remember though, you have to use these points, not these, but you need to use 1, 65 and 6.5, 23. So you no change to the y values, but for the x values, add 1 because you see that plus 1 there. Those are the 2 points you're going to plug in. Click logarithmic regression. This is your equation. And so here you should get a to just be 65 and b to be negative 22.438. And that is going to be our answer there. Right, part B. For B1, use the given data to find the average rate of change from 0 to 5.5. So it's just using the two coordinates. It actually doesn't matter whether you use 0, comma 65 and then 5.5 comma 23, or you could use 1 comma 65 and then 6.5 comma 23. You will get the same answer. Here, when we plugged it into Desmos, remember the slope formula is y2 minus y1 over x2 minus x1. This is going to be our answer here. So this is equal to negative 7.636. And that is going to be our decimal approximation. So make sure you show your work, show that fraction, show it even what you plug into Desmos, and then give me a decimal approximation with 3 decimal places. Part 2, interpret the meaning of your answer from part 1 in the context of the problem. And so what we're going to do here is use that template that we did in the 2.14 notes. If you forgot it, go back to it. It's still in that PowerPoint video. So this is going to be from t equals 0 to t equals 5.5 on average. And then I would say you want to give the noun of what's changing. So here, the percentage of US adults that did not own a smartphone. And here, I know it's tedious to write it all out, but on the AP exam, write it all out. On a test, write it all out. You only have to do this a couple of times. So the percentage of US adults that did not own a smartphone, and then we are either going to say increased or decreased. Here we're going to say decreased because our answer to part 1 was a negative number. So here it decreased at a rate of, and then we give our number. Because it's negative, but we already said decreased, so we do not need to say negative 7.636. That decreased kind of accounts for that negative sign. So decreased at a rate of 7.636, and then it will give you this percent per year. And that is going to be how we wrap it up. And so that's a perfect answer to part 2. I would be looking for almost all of this. So this is something that I would commit the format to memory and then plug it in based on the context of your story. Right, part 3. Let A of t represent the estimate for the percentage of US adults that did not own a smartphone. Using the average rate of change, find or explain why the straight line is below A of t, where t is between 0 and 5.5. So if we take a look here, right, the percentage decreased. So this graph is going to look like this. And so from 0 to 5.5, right? If we draw that straight line between these two, that straight line between 0 and 5.5 is going to be above the regression line, right? That S of t. So this right here is S of t, and this right here is A of t. So why is A of t going to be above S of t when t is between those 2 points? And here is how we want to answer. So first, say what you're trying to explain. So here we can just copy this verbatim. S of t is less than A of t when t is between 0 and 5.5 because, and then we want to talk about the graph or the concavity of S. So because S is concave down, or whoops, sorry, this should be concave up because it's an upwards U shape. So because S is concave up, and then you want to reference the secant line. So end the secant line from 0, or from t equals 0 to t equals 5.5 is, and then in this case, it's above S of t. And that would be perfect. That would get you full points. And so that is what I'm looking for. The main two things here are the fact that it's concave up and the secant line from 0 and 5. Those are the 2 points that formed it. Is just like above S of t, something like that. So that would be a perfect explanation there. Right, part 3, it was reported that the percentage of US adults that did not own a smartphone actually increased after 5.5 years. So here, let's say this is 5.5, and so this is our S of t, right? However, we are given that at 5.5, the percentage of US adults, no matter what happened, just increased, right? It kept going up. And so explain why the error in the model increases after 5.5. And that's because the error is going to be the distance that we were basically wrong with our prediction, right? And it's going to keep getting bigger because one's going to go up and one's going to go down, meaning the space between them is going to get larger as you obviously go further along to the right. So let's explain this. I would say the error in the model S, so get used to writing full sentences for these few questions, increases after t equals 5.5 because S decreases after 5.5 while the actual percentage increases. So while the actual percentage increases, so the distance between them is increasing over time. And that should be our answer to part C there. All right, 23. This is going to be a calculator question as well, just like the one before that we just did. A function is increasing and defined for x is greater than 0. The value or the table gives values of f of x at selected values of x. The function g is given by -2 log base x. Here we want to first find h of 20. So here, remember, h of 20 is going to be g of f of 20. F of 20 from the table is just 80. So this is just g of 80, which is, you are going to just plug 80 into that function, which is -2 log x, and you're plugging in 80 for x. That's your answer. So here we can just type -3.806, or write it down, not type, and that is our answer for part 1. Part 2, find all values of x for which f of x equals 10, or indicate that there are no such values. This is pretty easy as well. X is just 5. That's the only time we see this equal to 10, so that would be our answer for part 2. For part BI, find all values of x as decimal approximations for which g of x is equal to -3. So we're going to do two things here. We're going to graph the equation of g of x, and then, so that's our first equation, 1. Then graph this equation, type it in verbatim, that's number 2, right? And so once you have that, find your intersection point. It may take a little bit of work to do, but there we go. And usually if you hover your mouse over it, it will show up as gray. And so our answer here is going to be x equals 31.62, and then I'm going to round that up to 3. That should be our answer for BI. Part 2, determine the end behavior of g of x as x increases without bounds. Express your answer using the mathematical notation of a limit. And so here we have a negative a value, right? So this is going to look like that general shape. And so here the limit as x increases without bounds, so as x goes to positive infinity, of g of x, this is equal to negative infinity, and that should be our answer there. All right, part C. Based on the table, which of the following function types best models this function: linear, quadratic, exponential, or logarithmic? So looking at this, I see an addition rule up top, right? Plus 5, plus 5, plus 5, plus 5. And then I see a multiplication rule here, times 2, times 2, times 2, times 2. And so with a addition rule up top and a multiplication rule at the bottom, this is going to be best modeled by an exponential. And that's all you need to write. You don't need to write anymore. So exponential, and then here, for our reason, we want to say over equally spaced inputs, the outputs change proportionately by a factor of, and then in this case, our multiplication rules too. So that is our factor. So for this one, I'm looking for three things. You just talked about how the inputs are equally spaced. The outputs change proportionately, right? Which means that's our fancy way of saying a multiplication rule. And then you to give the exact number that the factor is by. So I'm looking for that number 2 there as well. So that is my answer to 23C. If you guys have any other questions, please come see me during office hours. I'll be happy to answer them, and I will see you guys later. Thanks.